Greetings and welcome once again to my new calculus channel. My name is John Gabriel. So, what am I going to talk about today? Something very important. My very first video was about an arithmetic mean, and that was approximately 9 years ago. And since then, I've shared a lot more information, but people still don't realize, especially mainstream academics, don't realize how important the concept of arithmetic mean, or rather, more correctly stated, level magnitude is. And the reason for that is they don't understand what an arithmetic mean actually is. They know how to construct one, it's very easy. But how to define it, what is it? They don't really know. They have no clue, in fact. And it happens to be the second most important concept in mathematics, with the first one being the concept of number. So let's look at the correct terminology, which is level magnitude. So what is a level magnitude, by the way? If you're given a discrete group of lengths, okay, the level magnitude of these is determined as follows, without numbers, by the way. Let the lengths be denoted by P, Q, R, and S. Okay, so if we get a pen and we say these are the lengths, okay, so let's just pull up a paintbrush pad. And so we'll say that the lengths are, P, Q, R, and S, right? P, Q, R, and S. Then we take the smallest length, the minimum of these four, which in this case here is P, right? It'll be this one here. And we subtract D from all the lengths and form one length W. So what that's saying is, let's take these parts, these remainders, and make one nice long line, okay, out of them. Just by joining them, I mean, you can take a compass and a straight edge and you can join all those lines. Then redistribute W equally among all the lengths. That's also easy to do in geometry, because if you have a length like that and you know there are 1, 2, 3, 4, then all you do is you just space your divider evenly like that, okay? And then connect these two last points, and then all these parallel points, all these parallel lines will give you the arithmetic mean, okay? So that's how you can do it geometrically, not knowing anything about numbers. And it's not really an arithmetic mean, it's a level magnitude. Then a level magnitude is calculating using the measures of lengths P, Q, R, and S. So as you saw in this example, we just used a compass and divider to find the arithmetic mean. But if these have measures like 3, 5, 7, and 13, say for example, then what we can do is we can take the shortest measure, which is 3, subtract 3 from all the other remaining measures, and sum them to get 16, okay? So that means on this one here, you'd have 2 plus 4 plus 10, right? So you've got a total of 16. So this line here will be 16 units, abstract units, not physical units, but abstract units long. And then if you redistribute 16, that means adding 4 to all the lengths. And so your level magnitude or arithmetic mean, or the measure of your level magnitude, which is the arithmetic mean, is 7. And note that no numbers are required here, okay? Then, what does it mean to have the mean of continuous data? So, can you find the mean of continuous data like this? Well, there's actually a little condition here. If these functions here on the subintervals are smooth, yes, you can find the mean of continuous data. And to do that is very easy. You simply find the mean of the individual ones, okay? So the first one is 3, the second one is 7. I just mixed up 5 and 7 here. It doesn't matter, actually. 7, 5, and 13. And 7 is your arithmetic mean. But now you need to be very careful, because you can't just take all of those, add them up, and say that, as I have defined area to be the product of two arithmetic means, you can't say that it's 7 times the interval width, which is 8. And the reason that you can't say it is that these intervals are not equal, okay? The first two are 2 units long, the third one is 3 units long, and the fourth one is 1 unit long, okay? So the correct area would be to take this arithmetic mean and multiply it by this interval, then this arithmetic mean and multiplied by this interval, as you see here on the right, which will give you the correct area under the curve, which is 48, okay? And you cannot find the arithmetic mean of all the line intervals using one rule, okay? So you have to use more than one rule. Now, let's do a summary here. The mean value theorem states that the arithmetic mean for any function that is smooth, like this one here, okay, any function that is smooth over a given interval is possible, okay? And it's possible even without a primitive function, as long as this function is smooth. It is stated unremarkably in mainstream calculus books, because it talks about there being some parallel secant line. Even the ancient Greeks knew about that. It's old news, very old. And by the way, the mean value theorem is the reason that calculus works. So let's look at the correct statement. Correctly stated, the mean value theorem says, given any function f prime of x which is smooth over ab, okay, which is smooth over ab, the arithmetic mean, or more accurate name, level magnitude or level term of all the y-ordinates is given by this expression here. So f prime of c is equal to fb minus f of a over b minus a, where c is somewhere in the middle. Now remember, this is how the new calculus derivative is stated. It's stated using the mean value theorem. And the incorrigible morons like Professor Jack Hasinger, all the other prize apes on Quora, and Sci.Math, and Wikipedia, and all those other crap sites in the mainstream don't understand these things, never have never understood the mean value theorem, don't know why calculus works, but here I am telling you. So this is the correct statement. The fact that such a C exists is an unremarkable property of smooth functions. Okay, there's always at least one y-ordinate which represents the level magnitude of all the y-ordinates in the interval AB. So what this is saying is, what the mean value theorem is telling you is that if, let's get a new paintbrush. It's telling you that if you have any smooth function, like let's say you have a function with one rule, by the way, you can't have garbage like piecewise functions. That's just drivel. Okay. So if you have one rule over this interval here, AB, then it's telling you that there is at least one ordinate here that is the level magnitude of all the ordinates in this interval. In other words, innumerably many. And how is it made possible to find this? By using the mean value theorem, okay? Now you might say, well, that only works for functions with a primitive. Well, that's false, because if you have in your mainstream calculus no primitive function, you can do what's called numeric integration. And the reason that works is due to the fact that this is smooth and that there happens to be a primitive function, which you can't find in the mainstream because your calculus is such a load of crap in the mainstream. But in the new calculus, it's possible always to uh, systematically integrate any function. Okay? So the new calculus is superior. That your mainstream professor or your idiot teacher doesn't like it doesn't mean it's wrong. Okay? It just means that they're idiots. They were taught the wrong way. And as I said to you some time ago, that if you're taught the wrong way, you don't come off without scars. It leaves massive learning trauma. I mean, if you go to any mainstream site, you'll see idiots talking about axioms. They don't even know what an axiom is, but you'll see them blurting out, repeating crap that's been drilled into their heads by their crapologist mathematics educators, okay? Because they're all a bunch of morons. 99.99% of them are prize idiots. And so you'll see that again and again. Now, there is a book that I'm offering you free, by the way, and you'll get it on Academia. You have to log in, by the way. If you don't log in, you'll get the message that you're in the wrong aisle. So it's this book here. Let me just show you. Now you can buy it here or you can get it free. It would be nice if you buy it because I make my living now, or part of my living, by writing books like this. So you can get a book called The Importance of Learning. Okay, the importance of learning the right way. What does division mean in mathematics? And how does it affect all other arithmetic concepts and mathematics as a whole? This book is so important that even though I earned money off it already, some money, not much, let's go to reports here, I've decided to make it free. So if we go to the past month, let's go to the last. Now, how do I get to the past month? Anyway, here's the past month. So I've made quite a bit in the past month, quite a few royalties. And again here. But it's not enough for me to, if I consider the effect of not releasing it to mainstream and students, it's devastating. So I'm giving it to you free, okay? I'm giving it to you free on Academia. This is where you'll find it on Academia. You'll go to my profile, okay? And what will happen is you'll get a list of all my articles, and you'll see here it's already in the top 5. It's called Learning the Correct. You can download it here, but it's got a watermark, and you're not allowed to print it or share it. It's just for your own personal use. Okay, it's a very important book. It's probably not probably. It is the most important book. I'd say it's even more important than the book I wrote on the new calculus. That's how important it is. So download it, read it, and spare $10 or €10. You know, I get let's see, less than $12,000 a year in Social Security benefits. I'm under the poverty line. I don't get Medicaid anymore because I don't live in the US. I don't get food stamps because I'm no longer in the US. I would be getting these things if I were in the US. And basically paying all my Social Security to rent because, believe it or not, the cheapest room you can find in many of the areas is over $800 a month. So it's basically existing only, and not being able to earn a decent living. And I am the greatest mathematician today. It's a shame that I haven't been rewarded and I haven't been recognized. But people are libeling me and defaming my character. I mean, the very first person who wrote a website about me was some moron called Dennis Miller. He had a site called Logical Fallacies. And it's no longer there, by the way. He probably realized what a moron he was and took it down. But there are many others. There's that nincompoop James Meyer, who was corrected by somebody else about the new calculus, but still thinks that he's right. That's the definition of crackpot, is when you're presented with overwhelming evidence, and you can't change. And one of the reasons you can't change is that you have been taught the wrong way. Okay. And it does leave scars on you. In fact, it's harder for people to learn the correct things once they've been trained in the mainstream than if they hadn't been trained at all. Somebody asked me early on, was telling me that he finds it difficult to teach the new calculus to people. So I said, well, I had no problems teaching students in China. And that when I taught them the mainstream equivalent, they thought I was basically having them on. They were laughing at me. They said, "Oh, teacher John, you're joking with us now, right?" So I said, "No, I'm not joking with you. This is the BS that you have to learn for mainstream calculus and mathematics." So it's untrue. But in any case, I encourage you to become a follower on Academia.edu and to become a member of my YouTube channel. Please subscribe, click like, tell your friends about this. I have innumerably many enemies. Okay. And by the way, if you look at the comments, they're actively trying to stop me. Look at this guy here. You need to be stopped. I mean, I don't even know who this Pupil is. And I said to him, truth can't be stopped. You will be defeated and exposed for the fraud that you are and all your mainstream mathematics colleagues are. They're all frauds, by the way, because set theory, topology is not mathematics, and real analysis is that bullshit topic based on a non existent object, the real number. In other words, the real number does not exist as a well defined concept. It's 100% bullshit. So that's pretty much it. I'm John Gabriel. Till next time, this is New Calculus Channel. Goodbye.